In the specific case of our lab, we work with super-absorbent polymers. They are used in industry in the manufacture of disposable diapers, in agriculture for water retention, and subsequent slow release to keep plants hydrated for long periods of time. In the field of polyelectrolytes, we use these polymers to purify water for human consumption and in industrial waters so that they are not highly contaminated when they reach waterways. We focus above all on studying oxide materials in the form of nano-sized thin films. There are oxides that have specific electronic or conduction properties. There are magnetic oxides. There are superconducting oxides. So these are the materials we study. We are participating in two research lines. One of them is thin films, and the other line is composite materials. The applications we have obtained with the results of this research improve the useful life of tools. We are mainly talking about reamers, burrs, drills, and cutting tools whose durability improves when we harden them. The company saw the need to start with development in the area of research to improve its processes and to improve the quality of its products. What we did was to establish a work methodology consisting in obtaining a material that is not found locally. The result was that the material researched suggested for replacement of the previous material was appropriate for the new product. This was the basic conclusion obtained from the work conducted. The theoretical physics group has a number of research lines at this time. Basically, low-dimensionality semiconducting systems, such as wells, strings, quantum dots, and semiconductor heterostructures. It also works in the area of superconductivity by analyzing physical properties of mesoscopic superconductor systems. And a third line, which is a line related to quantum computing. The research we have been conducting has basically been in metal alloys, seeking to find properties in terms of mechanical resistance, corrosion resistance, and magnetic behavior. We are also in the field of iron alloys, seeking to establish optimum conditions of magnetic behavior in these alloys. We have delved into a preparation method called mechanical alloying, by virtue of which one can alloy elements, substances, and compounds that are not susceptible to alloying via conventional means of temperature elevation, by melting. Our group is fundamentally focused on ionic systems that replace liquid electrolytes for solid electrolytes. These solid electrolytes have many applications, not only in batteries, but also in the development of fuel cells to provide power in places where contamination is a problem. The development of these materials will allow for the development of microionics. What do they consist of? In developing increasingly smaller devices to reduce the size of energy sources. And this will be a development in step with microelectronics. The strategic alliance between the Aston Center for Technological Development for Technical Assistance to Industry and the Excellence Center for Novel Materials, where we have the firm intent not merely to provide a concrete solution to industry, but also to drive the capabilities of the national innovation system by articulating different factors. Our group has been working on the development of an active nanodust. Among the group's most recent achievements is that of having obtained a cementing material that is not based on Portland cement, but rather on the use of an industrial waste with which a high-performance concrete has been obtained, with high mechanical resistance at very short ages, even in hours. With this support, we have sought new developments of our products. And well, it's great to be able to develop products that aid builders. The first thing we thought of was to make smart windows. These smart windows will end up replacing air conditioning, both in automobiles as well as in buildings. Another project is on magnetic semiconducting materials. This makes switching speeds much faster, and with these materials we can make hard drives with much faster switching speeds in much shorter times. The thin films position line is based on understanding the basic or physical principles and the physical growth properties of films. This is why our strategy is to correlate the growth parameters as well as composition, microstructure, and physical properties of the films created. On the other hand, plasma physics leads us to many applications. Plasma today, as it is known, is the fourth state of matter, and it is involved in many physical processes with many applications. In this electronics group, we are fabricating thin films. These thin films have many applications. Fabricating detectors, sensors, light emitters, avalanche detectors that have a large number of applications in the study of many biomaterials. We hope to develop these devices to apply them in the study of the properties of bamboo, coffee, and other biomaterials. We have taken on the task of researching the influence of adding nanoparticles to different coatings. The application of these types of compounds is mainly in very extreme conditions that take place in many industries that use bearings or parts subjected to high speeds, which are exposed to high temperatures and to very aggressive environments. The group has been working since 1973, and it is currently divided into 4 research lines. One of them is devoted to the study of semiconducting devices and low dimensionality systems. Another line is the novel materials line. Another line is Mossbauer spectroscopy, very focused on the study of nanostructured systems, corrosion products. Another line is the computer simulation line, where we try to provide interpretation of a number of the properties we study in these materials. We are particularly interested in the development of new magnetic sensors and trying to see how to apply the knowledge behind nanoparticles to other fields, like medicine. The Atomic and Molecular Physics group is a theoretical group. Our work is centered on the quantum mechanical description of few body systems. And we have a mesoscopic system line that works on simulations of few body particle problems in semiconducting nanostructures, such as quantum dots, quantum wells, and those type of systems. And that is how we integrate with the Excellence Center. The research group on materials, processes, and design at Universidad del Norte is a leading group at the national level. It is part of the CENM network, and it is currently involved in a project developing new composite coatings for mixed corrosion environments. That is, in the presence of marine action and chemical contamination. There are frequent environments in our industry. Corrosion is a problem, which implies high costs to the industrial and electrical infrastructure in the Atlantic coast due to high temperatures, high humidity, and a marine environment, which all favor the occurrence of corrosion. Our laboratory sought, since 1996, to develop materials for the development of laser rods. And the other is in obtaining next-generation fiber optics. The research we carry out is basic research, but focused on practical applications. This is a purely theoretical group focused on low-dimensionality systems with applications in nanotechnology. We work with two particles, two electrons, excitons in self-assembled quantum dots, and in supercylindrical lattices. Optical characterization and reconnaissance processes